Modern language models that use linear attention or state spaces, like DeltaNet, gated DeltaNet, or Mamba, are fast and cheap. They compress everything they have read into one fixed-size recurrent state. That state is a brilliant generalizer, but a leaky memory. Once the number of distinct key-to-value associations exceeds its rank, new writes silently overwrite the old ones, and the model forgets the exact thing it just read. This fails exactly where full softmax attention still wins: multi-item recall, passkey retrieval, and verbatim distant copying. Hola gives linear attention a hippocampus, a small exact memory that stores the tokens that surprised it most. Here is the mechanism. Linear attention's recurrent state is updated by the delta rule. Each new token adds a rank 1 update whose size is its write gate beta times the residual, the part of the value the state cannot already predict. The key idea, that write magnitude, beta times the norm of the residual, is an intrinsic surprise score. It costs nothing to compute and it is fixed at write time. So Hola keeps a bounded cache of the top 64 tokens by surprise, regardless of distance. But storing an exact copy is useless if you read it like linear attention. A unit normalized query over 64 entries gives a perfect match only a few percent of the mass, so it degenerates into a soft average. Hola fixes the read with a decoupled RMS norm that restores the natural sharp logit scale, turning the cache into near argmax retrieval. Where does this sit? Linear attention is an excellent neocortex, a slow generalizer, and a terrible hippocampus, a fast exact store. That is the complementary learning system's framing borrowed from neuroscience. Prior fixes for long context select by recency. Sliding windows like streaming LLM keep the newest tokens and drop the rest, so an old but important item slides out and is lost. HOLA is different. It does not ask how recent a token is, it asks how much it changed the state. A surprising token from far away stays. Recency barely beats no cache at the far needle, while surprise retrieval dominates. Two design choices, both load-bearing, and neither alone is enough. What to store? The top tokens by surprise, beta times the residual norm, not recency. How to read? A decoupled sharpened normalization that retrieves near argmax. Each choice in isolation gives a tiny gain. Together, on a 340 million parameter model, they cut Wikitext perplexity from 27.3 to 22.9, a 16% drop, and that lands below full softmax attention. The combination is the contribution, not either piece alone. Now the numbers: perplexity at 340 million parameters trained on 15 billion tokens. The same backbone gated DeltaNet scores 27.3. Hola, same backbone, only adds the bounded cache, scores 22.9. That is a 16% reduction, and it lands below full softmax attention, which sits at 26.9 at a fraction of the compute. The same roughly 16% gain holds at 46 million and at 170 million parameters. It is consistent across scale, and it is long context where the gap explodes. On the ruler benchmark, single needle retrieval at 32,000 tokens, 16 times the training length. The base linear attention model collapses to 0.14. A recency cache barely helps, 0.24. Hola holds 0.58. Even full softmax attention trained at 2,000 tokens collapses to 0 there because its positional encoding cannot extrapolate that far. Hola narrows but does not close the gap to a full attention model trained at that length, but against every linear baseline it is not close, and you can see exactly what changes. The base model's recurrent state is lossy. Distant, surprising tokens get overwritten and fade, and you can watch the recall drop with distance. With Hola, those exact tokens are retained in a bounded store and retrieved sharply on demand. The model is no longer guessing. The tokens it changed the most for are the tokens it remembers exactly, across distance. The recurrent update already exposes what to cache. You just have to spend the memory on it. Honest scope. 5 caveats. First, the cache is bounded, around 320 tokens, so single needle recall at 32,000 is 0.58, not perfect, and very dense context cannot retain everything. Second, the main scale results are single seed, with no confidence intervals, though the matched controls support the claim. Third, against full attention trained at that length, Hola still trails on pure token extraction tasks. Fourth, there is no matched memory comparison to learned eviction modules like LTE. Fifth, the sharpening arithmetic is a stated heuristic, not rederived here. Hola is the channel's first linear attention architecture paper, and its claim is elegant. A model's own update rule already diagnoses what it fails to remember. Spend a small exact memory on exactly those surprising tokens, read it sharply, and you recover the long-range exact recall the compressor loses. Subscribe for the next paper breakdown.